Very good afternoon to all the faculties of RNG Patel Institute of Technology and all the viewers who joined us online. I'm Dr. Madhvi Desai, Head of Computer Science and Engineering Department. Welcome you all for the webinar series organized by the department. In this webinar series, our today's topic is mobile and optical fiber communication. And for that, we have academic expert Miss Tithi Vyas, who is assistant professor from Raksha Shakti University. Welcome, ma'am, to our RNGPIT family, and for thank you for accepting our request. Now,
Thank you
I
so much.
request Professor Bhagyasri Patel, ma'am, who is assistant professor from CSE RNGPIT and moderator of this webinar, to introduce our expert and a brief description about our today's webinar.
Thank you, ma'am. I'm Bhagyasri Patel, working as an assistant professor in Computer Science and Engineering Department at RNG Patel Institute of Technology. I would like to welcome all of you on this webinar. We have arranged the webinar on mobile and optical fiber communication. For that, we have eminent speaker, Ms. Tithi Vyas, ma'am. I would like to introduce Tithi ma'am. Ms. Tithi Vyas ma'am is currently serving at Raksha Shakti University as an assistant professor, and she is the course coordinator for the postgraduate diploma in security communication and technology. She has an academic experience of more than 4 years and has various research papers to her credit. She has represented her institute in many educational fairs. Currently, she is working in the communication and telecommunication field that is used even in the law enforcement wings of India. Today, we have also Dr. Madhvi Desai, ma'am, Head of Computer Science and Engineering Department, as a panel member for this session. I would like to welcome both of you, ma'am. Now, without taking much time, I would like to request Tithi, ma'am, to start the session.
Thank you so much for the introduction, and I'll just share the screen.
Yes, ma'am. Ma'am, it is visible. Yes,
Okay,
ma'am.
and am I audible? I hope clearly.
Yes, ma'am, you are audible. Yes.
So, good afternoon, everyone. And as you know, that the communication is a very vast field. We have wireless communication, we have satellite communication, optical fiber communication, mobile communication. All these are individual fields, and they have so many aspects in them, their own selves to be studied. But today I have selected the topic that is mobile and optical fiber communication. Now, if you see that both are individual fields, but they are inseparable in certain manners, and they are interconnected in certain manners, and that is what we are going to establish today from the presentation. This is the outline of the presentation, and first I would like to talk about the concept of modulation. Now, first, let us assume that you are in a particular city of Gujarat and you want to travel to either Rajasthan or Sikkim or Kerala or Jammu Kashmir within the Indian border, but you want to travel somewhere. How will you go? Will you walk there? Will you take a bicycle? Will you take a two-wheeler or four-wheeler or a train or an aeroplane? Your answer would be depending on the distance. Whatever distance you want to travel down, you will choose your particular vehicle, right? So that vehicle is what? That is your carrier, something that carries you from one place to your destination location. Why do you need the carrier? Because you are not capable of walking or bicycling there, and you might even reach there if you want to walk, but it is going to take a lot of time. And in today's era, when we want some information just by clicking somewhere and within the split of a second, it is not possible that you would choose to walk somewhere. You would rather take a flight or a train, right? Similarly, if your particular signal of data wants to travel from one location to another, for an example, you call within your state, your city, internationally even. So when your signal is trying to reach to a particular destination location, it doesn't have the strength in its own self. So it will need a vehicle that is a carrier that will carry it from its source location to its destination location. So that is the concept of modulation, where you superimpose two signals. Now here, as you can see in the diagram, this is the second one is the carrier signal. Now carrier signal is what? It is going to carry you. And this is the input signal, that is your original data signal, information signal, right? If you can see, both have the difference of frequency. Now, what is frequency? You might have studied that f is equal to 1 by t. Or in simple dictionary terminology, if you say, then a frequency is occurring of something in a unit time period. How many times something occurs in a unit time period? So if you can see, if you take this particular horizontal line on the scale of 5 seconds, if this is representing 5 seconds, then you can see the period of this particular waveform being repeated hardly 2 times. Whereas here it is repeating multiple times. So you can see that this is a higher frequency signal, whereas this one is the lower frequency signal. So the lower frequency information signal might not be able to travel to your destination location, and that is why you need this carrier. This is a high frequency signal, that is why it is responsible for a flawless data transmission. Now, how do both of them travel? You need to superimpose these two signals, and that is called as modulation. So depending on various techniques being used, you can modulate the signal. Here I have represented only two. One is amplitude modulation, another one is frequency modulation. So as per the name, whatever characteristic is there is being modified. Where? In the carrier signal. So if you say amplitude modulation, then the amplitude, that is the shape of the input signal, remains, and the amplitude of the carrier signal accordingly changes. So as you can see, the frequency is of carrier signal here. It is same as the carrier signal, but the shape of the input, that is the amplitude, is kept. That is the concept of amplitude modulation. And the next one is frequency modulation, wherein the frequency of the carrier, see here the amplitude is same, the height is same, but the carrier signal is being changed by the characteristic of frequency of the original signal. So here the changes in the frequency. Similarly, the phase modulation can also be done. Now FM is very famous. You might be listening to the radio every day, and radio has what? Different stations. They have FM, like you keep it Vivid Bharati or Radio Mirchi. They have like 98.3 FM. So FM is frequency modulation. That is the concept being used there. And this is very important whenever you want to send any kind of a signal anywhere, right? Now coming back to the concept of mobile. What happens exactly when you want to call someone, right? So let us see a video. Here, whenever you are talking something, whatever you're speaking is getting converted to a microphone. So as you can see that this is an analog signal, whatever you speak, like my voice that is coming to you right now, I am speaking, that is an analog signal. But the computers or the mobile phones understand only the digital, or I would say binary language, right? So the work of the microphone of the mobile is to convert the analog signal into digital signal, right? And for that they use different MEMS sensor, that is micro electromechanical sensors, and different ICs, and that is how they convert this into digital signal. And when they convert into digital signal, they are in the form of zeros and ones, that is the binary signal. Now, this binary signal or digital signal is received by the antenna of the mobile, and this is converted then into electromagnetic wave depending on whatever technology you choose. Suppose you are using frequency or amplitude characteristic of that thing, then those binary data would be converted into equivalent electromagnetic wave. How? Suppose zeros and ones. Suppose you are saying hello, and this is the binary series 101101. Then you are transmitting basically this, but electromagnetic is a wave. It is not a binary data. So suppose there is just two things, right? 0 and 1. So suppose 1 has the higher frequency and 0 has the lower frequency. So this is how higher lower combination of the frequencies is converted, and that is how the electromagnetic signal is sent. Now, do you think it just by sending this electromagnetic signal outside your mobile phone establishes the connection to the receiver end? Think again. See, when your antenna is throwing this electromagnetic wave into the atmosphere, the receiver might receive it if it is just standing next to it. but we are using mobile phones to establish international connectivity. And when you are trying to do that, many things play their roles. Like there are physical obstacles, objects in between, like buildings or some sort of hill or even watery surface. Or there are electromagnetic or electronic or electrical equipments in between. There can be environmental effects, like there is a fog or there is rain. All these things play a vital role in obstructing the signal, and that is why it becomes very weak. So that weak signal might not be able to find its receiving end. If all these factors are absent, then also the curvature of the earth, you know that earth is not a straight plane, whereas the signal travels straight. So because of the curvature of the earth, it is not possible that you can establish a call for a long distance. So what you would do, this electromagnetic signal going out, will they connect to the satellites? No. You know the concept, that is the network tower. You know, you say it always that there's no network, there's no tower. So what you need is the cellular technology or cellular concept. You might be aware that there are multiple towers, network towers established in your own area. If you travel down 5 kilometers, you will see at least one nowadays. So what we do is, in order to send this particular electromagnetic signal, we have a particular tower nearby our location, right? So that particular tower in your location just captures that signal, then that tower radiates it to the receiver's tower. So if suppose you are trying to establish a call to your mother, and if you are living in Surat, then your mother is in Ahmedabad, how will you do it? So your tower in Surat will try to connect to the your mother's tower in the Ahmedabad city, and that is why you require towers. Now, as you can see that here I have just shown India, but the entire world is divided into these cell. That is why it is a cellular mobile or cellular technology or cellular concept. So these cells have a particular tower, and that tower is responsible just to send the data or its radiation or its electromagnetic wave within the boundary of this particular cell. As you can see, we have shown that this is a hexagonal cell. How about any other shape? Now, if you consider this tower to be a point, then a point radiates in all the direction. The radiation is in all the direction, and that all the direction means 360-degree that you are covering. And if you are covering 360-degree, the ideal shape should be a circle, right? But if we place circles adjacently, then either there would be overlapping, or the area between the three circles would be uncovered. And in that case, it would be difficult for us to establish any sort of network in that particular area. And that's why, because the circle does not have sides, we cannot place it adjacently. So how about square or triangle or any other shape? Well, they are not very near to the concept of circle. We know that the tower would be establishing its radiation in a circular manner. So if it is not near to circle, it is not helpful. And that's why hexagon. And here also you can think of more shapes like more than that, that is decagon, octagon. But that we are not selecting, because here there is a concept of cluster as well, and that is in detail, but we'll discuss it along with our presentation. So I hope that is clear that we are using the cellular concept. One tower in your location is trying to establish a call to the receiver end that is located in some other cell area, right? Now, how does this entire process work? Let's see. This is a mobile phone system. Let's first analyze the diagram. Suppose this mobile station. Now, when I say mobile station, it is a user. If that mobile is in your hand, you are the user. If it is in my hand, I am the user. So if this person, this mobile station, is trying to establish a call with this particular mobile station, right? So how does that call reach? First term we'll learn is base transceiver station. Now transceiver is transmitter plus receiver, right? So base means that is your base location, right? Apna adda. So base location, so base transmitter receiver station. That means this mobile is connected to this particular tower in that area, and this mobile phone is connected to this particular tower in that area. So that is your tower, nothing else. And now various towers in a particular area is connected to BSC, that is base station controller. Various base station are being controlled by BSC, right? So all these towers will be reporting to a BSC, and the master controller of this entire system is known as Mobile Switching Center, MSC, right? So you know, up to the towers, multiple towers being connected to BSC and multiple BSCs being connected to the master controller, that is your MSC, Mobile Switching Center. As you can just understand, it is Mobile Switching Center. So you're switching the calls, right? So when you try to establish a call, suppose this phone is trying to establish a call, so that would send the electromagnetic signal to this particular BTS in its own location. That BTS will forward its request to this BSC, and BSC will forward its request to MSC. Now MSC is very interesting because it is the master controller. What does it have? It has all the SIM card location, if that is your home MSC. Now any SIM card in the world will be having its particular one home location MSC, right? So this home MSC would be having all the data related to your SIM card, be it your location details or the active plans or whatever service plans you are having in your phone. It will be having all the details. Also, if you are not in the home location, suppose you have purchased the SIM card from a nearby store, so that is your home location, right? But if you are traveling to some other state, then that home MSC will know that you are in this particular area, because after every certain time period, it will keep on updating the location. The phone will, or the SIM card will keep on updating the location, and that location the MSC has. So based on that location data, MSC will always know in which other, or I would say foreign MSC you are in. So home location ke alawa jo bhi hai, that is known as your foreign MSC. So always the home location would be having the idea where you are. If you switch off the phone and switch on after going to some other state or other country, it will still be recorded that now it is open. So it is there here. So that means they would have traveled from the last location to this location, correct? So when the MSC receives your request, it will try to send the request to the home MSC of the receiver's end. So if you are calling your mother, the home location or home MSC of your mother's mobile station will receive the request, right? Now, if your mother is in the home MSC, she'll directly get the call through the chain that I'm showing, this, right? The reverse chain. But if she's not in the home location, home MSC, then the MSC will forward the call into the foreign MSC, and then this similar path will get established. So when you dial the call, it's matter of a few seconds, a few bits that your call gets connected, but this is the entire process that takes place in between, right? And it is very fast. So when you try to establish a call even in the north part of the India or south part of the India, it reaches quite fast if it has to travel down all these places, right? So while you are traveling all these places, it doesn't have a wireless communication, it has a wired communication. So from your mobile to the tower, it might be wireless, right? But from tower to BSC to MSC, all these things are connected with the wires. So an independent wireless system is not possible. There has to be some wired connection. I hope that makes sense now, that how your phone gets established. Now, when you are actually doing all these things, there is a particular frequency on which your phone is being established. Do you think that all the people in the world will be having their own individual frequencies? No, it is not possible, because we have the limitation of the bandwidth. We cannot have it on the infinite scale, right? So frequency reuse, the concept of frequency reuse comes into the picture. wherein we reuse the frequency after a certain distance, right? As you can see in the diagram, the very center cell, that is the green cell, has a tower, and all the other green cells will be having the same frequency as that is used in this particular cell. Similarly, all the same colors here, like this is purple, then all the purples would be having the same red, yellow, all of them are sharing the same frequency of its kind, right? And this flower like structure in the center is the cluster of 7 cells. So this particular thing has all the different frequencies so that there is no interference. But after the border of this cluster, there can be another cluster, and that can be reusing the entire frequency region, right? Now, what is the advantage of doing that? First is many transmitters of small output power. When you are having a transmitter of small output power operating at the same frequency, that can be used. That is what we discussed. And the other advantage is it reduces the minimum height of the transmitter antenna. Now you know that the frequency and the height of the antenna has a relation. So when you are trying to establish this thing, they have to be traded off. So after a certain height, we cannot establish the antenna. You know that more the height, it will be covering more the area, but then it will take the same raw material and everything, and it is not feasible these days because we are having so many towers, network towers available in a particular city. So this reduces the requirement of the height. But at the same time, if this entire system is not designed properly, it has its own disadvantage. And that disadvantage is called as co-channel interference. Co-channel interference is a phenomena where two frequency signals of adjacent channels interfere with each other. Now, what do you mean by that? You might be tuning into some frequency in the radio, right? At some point of time, you might be able to hear two different stations at the same time. Of course, none of them being very clear, but you will be able to listen to them. Why? Because they are placed very near to each other in the frequency spectrum, and because of that there is a co-channel interference, right? They are very adjacent, and that is why there's a point in between where you might be able to listen to both. So they need proper guarding in between them. So there has to be a proper distance in between, right? So this is the concept of frequency reuse. Now, if your traffic or the requirement in a particular place is beyond the limit of this regular cell size, then what will you do? So these regular cells are known as microcell, but you can then uh, divide that particular radius of that microcell into two, and that is how, sorry, macrocell into two, and that is how you derive the microcells. So that is the concept of cell splitting. If the traffic in a particular area, like mega cities, suppose Mumbai, there are so many people, so the traffic would be huge. So in that case, this particular basic cell structure would be further splitted into microcells, right? And if the requirement prevails, they can be even narrowed down. They can be even splitted into picocells, right? And that covers particular areas like building or tunnels, right? So these are the cellular concept. Okay, so now you know how you establish a call, right? How the cells are used. You know the network since like uh, schooling, but now you know exactly how they work. But you also know that when you are traveling, right, and you are on the call, what exact procedure happens? Now I'm playing a video. This particular concept is known as handoff, right? So handoff procedure is what? You are traveling from area A to area B, from one cell to another cell. And while you are in area A, it has a strong hold on your device. But once you are reaching at its border, right, at boundary, it will be having its minimum strength on your phone, right? So at boundary, hold of the antenna A on the device is minimum. At boundary, both the antennas will be having the minimum control on your device. Now, as you move further in area B after this particular point, right, then the hold of area A will be reduced and the hold of area B's tower will be increasing. and increasing when you are entering the region. Similarly, when you leave the area B as well, that cell, when you are leaving, then again the same scenario happens. So this is like area A's tower is is handling over the responsibility of that call to the tower of area B, and that particular process is called as handoff. So you are handling over the responsibility, right? Now, when you are traveling, it can be a smooth handoff, right? When the antennas prevail after very significant distances, it is a soft handoff. So you don't really understand that you just changed the area and that is why your phone faced any sort of problem. But there are times when your call doesn't get established. They might get just dropped. So you have to redial if you want to continue the talk. But there are cases when the call doesn't get disconnected and it is nor a soft or smooth handoff. At that times, for a few seconds, you might feel that you can't listen to anything. The call just got faded away, or there is some sort of disconnection, or there is some sort of reconnecting happening. That particular thing is called as hard handoff. So handling over the responsibility, that means when you are traveling from one cell to another cell, this particular thing is called as handoff. You are handling the call, and then you are transferring the responsibility to another tower, that is handoff. It can be a soft handoff, it can be a hard handoff, or the call may just drop down. So these three concepts of handoff you should also know. So now maybe you just know everything related to the call establishment, but it has its history as well. The mobile phone today that you are using has its entire history by naming them into different generations. So 1G, 2G, 3G, 4G. As you can see in the diagram, you can remember that the first one is the cordless phone. Cordless phone did not have a wire. So basically, wireless first ever connection, but it was able to only dial the call. No other services available. Frequency slot distribution was used. Frequency division multiplexing, multiple access were used, but it was not enough for us. The speed was also very less. So we shifted to the 2G, second generation mobile phones that introduced the concept of SMS, short message services. Also, there was a GPRS internet connection available. The speed increased, but still only to a certain extent. There came a technology and which is available on the internet as well, called as 2.5G, that is in between 2G and 3G, which had more speed than 2G but not yet into the smartphone era, right? So as the time progressed, we just needed more speed of internet. So from 2.4 kbps of 1G to 3G, which was a huge revolution in the telecommunication industry, had 2 mbps of speed, right? It used the concept of WCDMA, that is wideband uh, CDMA, that is code division multiple access, while 2G had just GSM, CDMA, TDMA techniques available. 3G introduced the smartphone in every house. You were able to download things, you were able to uh, access various social media, social networking apps. There were a lot of internet usage. So that was the 3G wireless connection. And today we are in the generation of 4G, where we are using LTE, VoLTE, IP based protocols. We are using the OFDM, that is orthogonal frequency division multiplexing, and MIMO technology, multiple input, multiple output. MIMO basically uses multiple transmitter receiver antenna inside both the mobiles and the towers. So basically, within the given bandwidth, the speed is increased. So you can use it in a very good manner. So that is the current 4G technology where we are using the 100 Mbps of speed, and we are shifting and trying to shift into the 5G. 5G will be having advanced MIMO technology and millimeter wave concept. And basically, when we talk about 5G, we are talking about IoT, Internet of Things, that will be enabling us to use like driverless cars, or will be having the smart cities, smart homes kind of the idea. So from 4G to 5G, and this is going to revolutionize even again and again in the future, right? So after knowing all these about mobile phones, from this slide, you might be having one question. That is the difference between GSM and CDMA. Now, if you study a book or even Google it down, there can be various difference that you study in the book, right? But the basic practical difference between a GSM and CDMA phone, which was available since the 3G technology, is before that, GSM is global system for mobile and CDMA is code division multiple access, right? The practical difference between the two is the availability of the SIM card port. Now in India, we have been very used to the concept of SIM card. We have changed a lot of phones, or we might have changed a lot of SIMs, keeping the mobile same, right? So being able to change a SIM card from one phone to another, or the same SIM card, but you are changing the phones. So you are just simply supposed to insert the SIM card in the phone. And that is the technology of GSM. What about CDMA? Well, CDMA, if you know anyone from abroad, someone from US or any other part of the world, they have this locking, unlocking of phone concept. If someone is bringing their phone here and you have to unlock the phone, what is it? Uh, in those countries, whatever phone you purchase, they have their predefined signal of mobile, like SIM cards, feed it to that phone. So that particular phone will work only with that particular plan. So it's a combined combination plan. So what you do, you purchase a phone and it is already having a pre-feeded available SIM card, but you cannot just remove it. It works just like that. So the availability of SIM card is the basic difference. But there are now phones that are working on CDMA concept, but they have the SIM card port available. Then do they work on GSM? No. Nowadays, the difference is that you are able to establish the call through LTE, VoLTE, voice over LTE, long-term evolution. That is, you are establishing the call through internet. So earlier, what happened was either your phone call was there that was being uh, received, or you might be able to just Google something. So basically, what I'm trying to say is accessibility. Either you could be on call or you could be using the internet. Both of them were not happening at the same time. But nowadays, you can. While you are on the phone, you might be receiving the messages in the background. So that happens because of the LTE concept. And in these days, CDMA uses that concept, that you are establishing the call through the internet. So that is the basic difference. Now, all the while we have been talking about mobile communication, that call is reaching to us in 3G, 4G, 5G technology, the browser through which we are Googling something, like you are using Facebook or WhatsApp or Instagram, or you are accessing your email, you are browsing some data, or any sort of, or even this particular voice that is coming to you, you are able to see the presentation. All this data is coming to you via internet. How does it come to you? Right? How does the data travel so long to reach to you? So let's first see that we have data centers established in the world, and they might be miles and miles away from you, having all the data stored within it. Suppose you are asking some YouTube video to be played, you are asking a particular movie to be downloaded, you are asking a particular page of the Facebook to be opened. All these data are having some page IP address. This IP address is its address, right? So if when you are requesting something, that particular IP address is called. When it is called, this particular data center located miles and miles away tries to send you the data. Now, how will it send the data? It might just send it to the satellite, and that satellite might just transmit to you. But when you talk about satellite, it is very kilometers and miles away from you. So in order to make it reach to you, you have to make the signal travel so long that it might not be reaching you in time. So it is not a feasible solution. So what happens at that time? So whatever data you are requesting is traveling to you through the optical cable. The optical cable will be in the zones like grounds, hilly area, or even watery surface, anywhere on the different terrains, and they will try to reach to you wherever you are in the world. These are called as submarine cables. We are talking about it in detail in the later slides. But the Google is the biggest, having the biggest share over the submarine cables. Now these cables under the sea, how they are, see, this is the technique that is being shown, how they are laid under the sea. So this particular device goes down to the surface level. It plows the plow, it trenches, the ducting and trenching technique is used. So it is fitted in a groove that is created by it. And this particular optical fiber then comes to your house, and the router converts that particular optical data into electrical signal, and that electrical signal might reach to your laptop through this particular Ethernet cable. But if you do not have the router and you are using the data pack, then that particular data pack is reaching to you through electromagnetic signal, and the same optical cable will be transferring the data to the tower, and the tower would be sharing the electromagnetic waves with you. So the optical cables are basically reaching to you through the router or through this particular tower. After that, you will be having an electrical signal or the electromagnetic waves, depending on whether you are using a router or the data pack. So this is the entire thing that happens. So that is why I said that they are interconnected in certain manner. What? Mobile and optical fibers. So the entire world is connected through the optical fiber cables, and wherever wireless things are there, but the basic wired connection in this internet era is this optical fiber, right? So if you can see, the optical fiber is on the planet, entirely covering the planet, so that wherever you go you have some sort of network. But in the very beginning, very initially, it was used only in the medical thing, that is the endoscopy. In endoscopy it was being used, you know that the camera type structure goes inside and it needs the light to see whatever is there, and optical fiber means the light. You are using the lightning fast speed, the light, visible light is being traveled. So what is inside this particular optical cable? As you can see, an optical fiber is of the diameter or radius of your hair. It is as thin as that particular hair of yours, right? So this is how it looks, and it has the core, cladding, protective shields, and strength members. Why you need the strength member is because you are making it travel so long, and it is very delicate like your hair. So as you can see in this entire picture, the optical fiber are occupying very little space, whereas the other things are used just to give it protection or the strength so that it can travel longer distances, right? Now, how does this particular sending the signal in the form of light works? So basically, you are not sending electricity, but you are sending the light. That works on the concept of refraction, right? You might be able to picturize something that you did in the school by seeing this particular image. There's a prism. The source of light can be anything, an LED, that is light emitting diode, or a laser. And when it travels from air to a particular different kind of a material that has different refractive index. See, the refraction happens when it travels from one medium to another medium, both having different diffractive index. So refraction is nothing but the ratio of speed of light in the vacuum to the speed of light in the particular medium. That is the ratio that is called as refraction. So this particular light doesn't go straight, but it bends here. So that is refraction. This particular bending of light is called as refraction. Understood? Now, the refraction of air is the least from, you consider glass or you consider water or any particular other thing. That is why when you put the pencil in a water glass, it looks like it is broken or bent. Now, if this particular material, that is the glass, is injected with something and I increase the refractive index. See, this injection is showing that I'm increasing the refractive index. With increase, this bending is changing. It is bending more and more and more up to a level where it is totally internally reflected. So the signal is having so much a refraction that total internal reflection happens. So this particular angle at which this total internal reflection happens is called as the critical angle, and that is the concept being used in optical fiber. You are establishing such a surface, such a difference of refractive index, that you can establish this internal reflection. This is a very simple little strand of optical fiber, right? uh, Circular opening, and that is known as core. So this core has this total internal reflection wherever you are using, and it is made by silica. Silica is SiO2, reti, what we call, right? So this is made from silica, and it happens because of the difference that high refractive glass and low refractive air. This is the difference that is used, and that is why the total internal reflection happens, but it is very delicate. So we need some protective, we have to put some protective coating over it. And that protecting coating, if applied, then this particular difference won't be created. So what we can do is we can create a cladding that would be having a refractive index that is less than the core. I'm repeating again. The core that is made from the silica has higher refractive indexes, whereas the air that is outside it has the lower refractive index, and that is why this internal reflection happens. But we need some protection because it is very delicate. So we are creating another feature, that is cladding, that will be having lower refractive index, just like the air had, than the core, and it will be used as the protection as well as the uh, in, coating and the lower refractive index product. Now the cladding will be having different doping of silica. So both are made from silica, but the different doping level can make us have different refractive index products. And at the angle that is greater than critical angle, this particular thing of internal reflection happens. So no leakage of the visible light. And this particular optical fiber that you just created might be able to travel up to 100 kilometer, and that is the signal strength. But after 100 kilometer, what? Because you are covering the entire world literally. So after 100 kilometers, what will happen is you will need some sort of amplifier or repeater. What will they do? They will boost the energy. They will boost the energy of that particular signal, so that amplifier or booster or repeaters are used, and then they are again sending it further. That is how the entire globe is covered, right? So optical fibers laid entirely in the world uh, can travel up to 100 kilometers without any sort of loss in the information. That is a huge accomplishment. So this is the actual map of the world, and as you can see, there are more than 400 connections, more than 400 optical fiber links under the sea, right? There is there in India as well. Mumbai, Chennai, Cochin, all those are having the lending offices. And this is the actual picture under the sea. And this is when from a lending station it is traveling inside the sea. So this is how it looks. See, this is the trenching. A groove is created so that it doesn't move, and it is going under the sea. Now, as I just discussed about the repeater or booster or amplifier, how does it get created inside the sea? Well, in that case, we just put the copper shell over this particular structure, and it provides the amplification within the optical fiber itself, and the insulator is there so that no leakage happens. Copper, because it can give the electric support to it in order to amplify the signal, right? Now this is the actual video how they establish this thing. So there is this in between tower, it's totally water, sea. So the tower has an open pre-installed messenger wire included entry hole cover, right? So we will continue from here to the next end. And this is the camera so that the ship submarine person can see how the work is going on inside. So that is how it will navigate it, how you can take control of the entire thing. And once that particular network is established, you will then start moving your ship towards the second end, and you will lay the wire, optical fiber wire from the ship. As you can see, it just traveled. So touchdown monitoring, this entire thing. This is the optical fiber getting laid from the submarine. This is the second end, right? When you reach to the second end, a cable is pulled down, and so that, see, it shouldn't be loose inside the surface of the sea. So you just put this entire mechanism down so that it is tight as well. The looseness in it will cause some sort of bending, and that bending will also cause you to lose some sort of information. So this entire thing happens, and then you can drop this post-lay trenching so that wherever the fiber is not placed properly, it can trench the cable there, and then it is called up from the submarine. So why are we using this optical fiber and not the copper? Because of these advantages. Other than costing, everything about the optical fiber is a plus plus thing, right? Safety, durability, the weight is very light because it is of the thickness of your hair. When you are transferring the data through the copper cable, at that time the magnetic radiation gets created around the particular cable, and because of that, the magnetic uh, radiation is created. Whereas in optical fibers, there is nothing, no kind of radiation is coming out. The bandwidth is also great in optical fiber, whereas it is not possible to get established in the copper cable. So that is the advantage. This is the basic optical fiber link. So if you see, this is electrical input and electrical output. So you need the electrical signal at the beginning and at the end. But when you want to make it travel a long distance, at that time in between, you need the optical fiber signal, right? And this is the optical splicer, because you cannot make such long the cable. So splicer is nothing but a joiner. It can join in between wherever the ends are, and it can. This is the generator, repeaters or regenerators or amplifiers as we just talked about, right? But when it is traveling, it can be different fiber optic cables. It can be single mode, so it is traveling in a straight line, or multi mode where the reflection happens, that we just talked about, and that is what is being used. But if the angles are different, it is called as step index. If it is in accordance with the others, it is called as graded index. The advantage of using graded index is less dispersion compared to this. What is dispersion? It is broadening of the signal. By the end, it reaches its destination place. When it broadens, that means two adjacent signal will get the crosstalk connection. So this dispersion should be avoided as much as possible. And while the entire data is traveling, other than dispersion, the other fiber loss that will happen is called as attenuation. So attenuation is largely determines the maximum repeater-less separation between optical transmitter and receiver. So attenuation happens. For an example, we just talked about 100 kilometers. After that, so by up to what distance no loss will occur, right? And so that is the repeater less separation between them. So attenuation also has three types. It's a loss, fiber loss. Attenuation can happen by three ways. First is absorption. So it is caused by the impurities of the fiber. When you make the fiber, there can be some impurities, some metals or water got inside. So there are further three classifications, that is intrinsic, extrinsic, and atomic, and further like absorption in an infrared or ultraviolet region. So basically, the signal within the cable gets absorbed. The other is scattering. When you try to fall some particular light on a particular surface, and if it is kind of not regular, it is not smooth, जैसे कि उबड़ खाबड़ है, then it will scatter in all the direction. So when you talk about scattering, what happens is it is because of somewhere there is a bump, somewhere there is something else. So if you look under the microscope, the surface is not actually very smooth. You feel it that it is smooth, but it is not actually very smooth, and because of that, the scattering happens. And the last kind of a loss, which is very important, is a bending loss. When you bend a particular wire, when it is bended, it is not straight, but it has a bending, that is microscopic bending. There is a loss of information if there is a lot of bending in between. And macroscopic means some, जैसे कि हम बात करें under the sea, so if some sort of rock falls on it or something, so it bends on a vertical manner, right? Some sort of stress is on it, so that is why it bends. Some surface gets some problem, so that is a macroscopic bending. So all these noises or losses are also part of the process of optical fiber, but still it is doing great other than the cost requirement. But this is the entire concept of mobile and optical fiber cable, and that is how they are interconnected, and that is how we are using in the current times. So that is it. I hope you understood.
Ma'am, can you please
Yes.
stop sharing your screen?
Yes.
Okay. Thank you, ma'am. Thank you for the wonderful session. Now we are moving towards the question answer round. Ma'am, we have so many questions in our live chat box. So, can we start?
Sure, ma'am.
Okay. Ma'am, the first question is, will intelligent buildings use fiber optics or copper wiring to carry voice, data, or video throughout the structure?
Okay, it's a very nice question, because when you talk about communication, there are two broad concepts. One is when you are talking about covering the entire world through internet, and that requires the optical fiber to the maximum level, because when you are talking about these things, the 70% of the entire system is covered through optical fiber, because you are covering long distances. But when you are talking about intelligent buildings, the building is just one entity at a one place, and laying optical fiber can be very costly, because you need maintenance, and up to at least 100 meters from your particular device, you need to establish the copper wiring. So we are coming up with very different techniques of establishing copper wiring nowadays, LED copper wiring connection, and many others. And because of that, intelligent buildings have the chance of establishing 60 to 70% of its entire coverage through copper wires only.
Okay, okay, ma'am. Ma'am, second question is, how does MIMO technology help in bandwidth requirement?
Okay. As I just mentioned, that MIMO is nothing but the multiple input, multiple output thing, and it basically has multiple transmitter receivers in antennas in both the mobile and the towers of the mobile. So basically, it uses the entire bandwidth available with it very efficiently. So you do not need more bandwidth in this
Okay,
particular
okay.
thing.
Ma'am, next question is there any security issue related with mobile computing?
Of course, there are many security issues. You are never too much safe in today's world. So, when you are talking about mobile computing, you are basically accessing some sort of data, right? And in that case, like WhatsApp gives you this end-to-end encryption
Yeah,
possible.
yeah.
But otherwise, anyone can just fish around your data and they can know. It is very easy to hack these days. So, of course, there are issues. It's a vast field again.
Yes. Ma'am, next question is what are the features of 5G and what is the difference between 4G and 5G?
The basic difference is the speed. See, 4G can establish 100 Mbps, and when we talk about 5G, it is in Gbps, 10 Gbps of data. So the features of 5G is that we will be using advanced MIMOs from the MIMO
Yes.
technique that we are using in 4G, and because of that, we are entering into the entire IoT zone. And IoT era will be having the entire smart thing that you can think of, smart city, driverless car, and everything, and that requires very high speed internet connectivity. So that is the basic difference in the features.
Ma'am, next question is what are the career opportunities in mobile and telecommunication sector?
Oh, it's a very broad field. So if you
Yes.
think about telecommunication sector, like I just mentioned in the very beginning of the presentation, that communication itself has various components like wireless or satellite or optical fiber or mobile. So when you talk about satellite communication, of course NASA and ISRO and the big known companies, but they also tie up with many small companies that will be providing them the raw material, or for an example, some prefabricated material. So you can be a product designer, you can be a hardware electronic designer. When you talk about mobile, you can work in any mobile operator companies like Geo or Vodafone or BSNL or so many, that provides you with the government opportunity as well,
Yes,
and in
go on.
defense as well. The police inspectors and the BSF officers and all of them are now being trained with the advanced training that is in the field of telecommunication and in cybersecurity, because most of the crimes that is happening today is related to these two fields, because we are living in the advanced era. So there are multiple opportunities in these fields.
Okay. Ma'am, next question is if the optical fiber is breakdown, then which techniques are used to repair or join the cable?
Actually, when that breaks down, depending on what kind of the problem that happened to the optical fiber, first that is needed to be identified. Like if it is undersea and it is getting cut, then a ship is sent, because you obviously realize कि यहाँ पे data नहीं आ रहा है. So
Yes.
you go and you check and you get both the ends on your submarine, and then it is through the process, through the fabrication process. जैसे हमने बोला splicing, that joins the two fiber, that is used. And there are multiple techniques otherwise as well. And this is basically for the undersea communication, because otherwise you can just dig down the surface and you can know where the problem is. But when you are talking about undersea, sea level is too deep. At that time, it becomes difficult. So this is how this entire thing works.
Okay. Ma'am, the last question is what kind of development is going on in India in the field of mobile communication currently, if you are considering?
Okay, so you know that other countries in the world are very advanced compared to India. So they
Yes.
do have this, you might be aware of the augmented reality and
Yes,
virtual
yes. VR
reality
and VR.
concept.
Yes.
So
Yes.
we are not yet so much aware about the things, the way the people outside India uses the technology. So when you talk about robotics, now
Yes.
robotics doesn't mean simple a robot, a human like
Yes.
robot, but so many. जैसे कि we talk about IoT. So there are
Yes.
sensors that help you identify what is happening, so
Yes.
that you can control through your mobile, right?
Mhm.
Also, we are increasing the speed. We are talking about internet connectivity. We are talking about security in mobile
Yes.
communication. So all these things are happening. We are talking about the intelligent smart cities and smart gadgets. So all
Yes.
that we are able to, जैसे कि घर पे AC है, we don't just need the remote. The MI remote is very famous these days, that you can operate through mobile only. So
Yes.
the sensor basically, or the way
Yes.
you use your particular internet connectivity to establish the connection, not just with someone on the other side of the call, but through any particular gadget, is very much in demand.
And some other questions are also there if you permit them.
We can take, I think, one or two.
Yes, yes. Ma'am, is there any technology beyond optical fiber which is even more effective?
In today's world, optical fiber is the thing if we are talk about today, right? But as we are coming up with the advanced technology in the copper cables, the similar thing can be there in future, that can be regarding optical fiber. But currently, if you talk about optical fiber is the most effective, because it is light in weight, it can travel up to a long distances, and
Yes.
it is very durable because it is so small in size. So when you talk about internet connectivity, since I have related mobile with optical fiber, that is the most effective technique.
Okay. Okay, ma'am. Thank you so much, ma'am, for the informative session. And now I'd like to thank Tithi Vyas, ma'am, for your valuable time and knowledge that you have shared with us. And I would also like to thank the management of RNGPIT and Principal Sir, Dr. Latesh B. Chaudhary, sir, for giving support to organize the wonderful webinar. I would also like to thank our head of the department, Dr. Madhvi V. Desai, ma'am, for continuous support for a webinar, and also would like to thank the department faculties and students, our alumni who have joined us for this webinar. Ma'am, thank you so much for joining us. There are so many good reviews we have received with the live comments also.
Thank you
So
so
they are
much.
also asking for the PPT. So I will share them the PPT also.
Surely, surely.
Uh, okay, ma'am. Thank you
Thank
so much.
you. Thank you.
Yes, yes, ma'am. Okay. So here we are ending the session.